Hello, this is Alec Dobos. I'm going to discuss our project for human factors and artificial intelligence project. So the first step is the analysis of the task. My problem that I have selected, it consists of trying to give a driver, either a residential driver or a commercial driver, the best commute time when they are traveling. The best commute time will equate to the route in which the driver encounters the least amount of traffic, generally. In the next portion, I need to identify the key task associated with our problem of having the shortest drive, basically, and perform a basic task analysis. My trigger is that there's ever worsening traffic congestion for both residential and commercial drivers in metropolitan and city areas. My first action is to check the traffic forecast, maybe a day or two before my expected travel, with my traffic analysis tool. I have to make a decision, choose the initiation time of the travel time. Quite often, folks, usually take the same route to work, for example, a residential driver, and, leaving home, on a different time may impact their commute to work, right? Sometimes it's, during rush hour, before rush hour, a little after, towards the end of rush hour. It can vary your time to get to your destination. Another action will be checking the weather forecast the night before travel. We would use some kind of weather app for that. And of course, the reason for that is because weather will impact travel. Any inclement weather could slow down traffic. Also, too, I've experienced, sun glare, depending on what way you're going, and in traffic, what time of day. You could have some sun glare that slows traffic down. Another decision would be after inputting the desired travel time start, we're going to use the traffic system analysis tool and follow the optimal path from the tool. Our objective is to choose the travel path which will minimize the time spent commuting basically between point A and point B. Stating my insights from the task analysis regarding how we might be able to simplify the task flow or improve the user's experience with the task. Part of the commute is dynamic. The weather might change during the commute, which could hinder traffic. After all, weather prediction is not 100% perfect, right? It might impact the commute while in transit. Also, it is possible that a vehicle might break down and block the road, or an accident could occur and block the road or cause slowdowns. We need a mechanism so that the user or the driver can start again with a new point A at the area where they're kind of stuck at, right, of the slowdown and delays. Thus, the traffic analysis tool could kind of like recalculate and come up with a new optimal path to finish the journey of the in-progress commute. Our user experience design. Explaining how the user will interact with our solution. The user will interact with the traffic analysis tool with either a GPS type of computer or tool in the vehicle, or maybe a cell phone that integrates with the onboard GPS computer. Somehow I believe Apple Play has one out there that actually does that when you plug in now. Describing the approach to each of the following key considerations of the artificial intelligence product user design. We have 3 parts to discuss. User inputs and any feedback loops. The user will input the starting and ending points of their desired commute, basically the source and target destination, right, into our computer. A feedback loop might be a direction or a roadway change for a commute that is in progress. Again, maybe there'll be, an accident or some kind of bottleneck or emergency road construction. So we have to kind of have some kind of feedback loop in there to kind of adjust, while we're in transit. We have to evaluate the transparency of the model. The model should allow users some level of insight on how the model is working. Maybe not all the detailed network analysis or mathematics behind the scenes, but at least allow the model to be interpretable and how the importance of the parameters the users choose might impact the outcome or results of the model. Our third part will be communicating uncertainty. There needs to be some kind of mechanism that will communicate in real time that delays might be coming, and a new route should be considered for an in-progress commute. This way, it gives a driver, an opportunity to figure out what's the backup plan, basically, to get another optimal commute, or I should say, another optimal pathway. Privacy considerations. We have to explain any privacy-related concerns stemming from the data that we collect and the use of our data in the AI system. You need to keep your starting and ending points of the driver's journey secret. Addresses are identifiable, which divulges personal identifiable information such as address, which in turn could be used indirectly to determine who lives at a residence or works at a particular business location. Furthermore, sensitive information, which is a deeper classification. For example, medical records or social security numbers, we will not be using them in our traffic analysis tool. They're not pertinent. We need to describe our privacy laws that are applicable to our traffic analysis product and what obligations they create for us. In the US, there are federal, state, and local privacy laws. In some states, the legal driving age is under the year of 18 years of age. How do we handle that private information of a child? There needs to be safeguards in place to protect this underage legal driver, but not yet considered an adult. The traffic analysis tool cannot collect or share any personal, identifiable information. Any of this personal, identifiable information must not be visible or distributed from the app or system. Ethical considerations. Identifying the main potential sources of bias. There could be some historical bias based on the time of collection of data, or learning bias, which might amplify, some of the bad parts of the model or performance of the model that might hinder it, the outputs. For example, during non-rush hour, the model might assume the highway is the better choice for the commute rather than local roads. And during rush hour, the model might throw in some local streets, partitioning, since many highways get backed up, and you might seek an alternative route around something on the highway, since it gets congested during the rush hour. We need to explain how our product will meet the 3 goals of ethical artificial intelligence. It needs to be fair. The traffic analysis tool will not discriminate. For instance, the tool will not consider the type of, the beginning or end points of your commute. Also needs to be accountable. The application will allow the user to have recourse and make parameter updates if they identify a potential issue with the mapped out commute. And also, we should be concerned with transparency. The traffic analysis application, the model should allow users some level of insight in how the model is working. It will explain the significance of the parameters and the instructions what to do if an outcome seems not desirable to the user, such as updating the parameters for a new path or allowing an override or designated stopover during a particular commuting path. And that concludes my discussion here. Thank you.